Assalamu alaikum. Welcome to the second part of your lecture today, in which we're going to discuss examples for data link layer protocols, packet over SONET, and ADS. So, packets over SONIC. SONIC is synchronous optical networking. It's a physical layer protocol for transmitting multiple digital bit streams over optical fiber links. It forms the backbone of the communication networks. POS, or Packet over SONET, is a standard that maps IP packets into SONET frames. To implement this, point-to-point protocol runs over IP routers. Point-to-point protocol is a data link layer protocol. It's used to transmit data between directly connected computers. As we see here, the protocol stack consists of IP on the top, point-to-point protocol in the link layer, SONET in the physical layer, where IP packets are encapsulated in point-to-point frames, and the point-to-point protocol frames are encapsulated in SONIC payloads. Point-to-point protocol provides three features: a framing method to indicate the start and the end of each frame and to deal with error detection and correction. A link control protocol for bringing up the links, negotiating the options, and tearing down the links. A negotiation method for the network layer options, and there are multiple network control layer frames, each for each one of the supported protocols. That's to say TCP/IP or SPX/IPX or AppleTalk, for example. The point-to-point protocol frame has two flags to indicate the beginning and the end of the frame. It has an address field that is always set to all ones to indicate that all stations has to accept the frame. A control field that is always set to zeros and one to indicate that this is an unnumbered frame, and to tell a protocol field to tell which protocol the payload is carrying, whether it was IP, CLP, or NCP. A payload which contains the upper layer protocol packet and a checksum to identify any errors in the transmission. The two fields, address and control, always have the same value. Before the point-to-point frames are sent over SONET lines, the point-to-point protocol link must be established and configured. This has 6 phases. Phase 1 is that when there is no physical connection. When the physical connection is established and the point-to-point peers exchange a series of link control protocol to select the point-to-point options successfully, this is when the link is established. Next, when the negotiation is successful, the two parties will check each other identities if desired. If the authentication is successful, then a series of network control protocol packets will be exchanged to configure the network layer. After this happens successfully, then the connection is open and the data is transported over SONET. Lastly, when the data transport finishes, the connection will be terminated. As we see here, the connection starts with dead, then the carrier line is detected. Next, the physical connection is established, and the negotiation between the two point-to-point protocol peers starts. sending a series of link control protocol packets. If the negotiation failed, we will go back to dead. If the negotiation was successful and the options are agreed upon, then we will move to authenticate. If the authentication was successful, we will move to network. Otherwise, if the authentication failed, we will move to terminate. At network, there will be configuration for the network layer using network layer control protocol. When this is done, the connection is open, the data is transported. After the data transportation has finished, then the connection will be terminated and the line will be dropped and we will go back to dead. A typical scenario for establishing connection will be a PC first called ISP router via a modem. The router's modem answers the phone and establishes physical connection. The PC will send the router link control protocol packets in the payload of the point-to-point protocol field, payload field, to negotiate point-to-point parameters to be used. Once the parameters were agreed upon, the series of network control packets will be sent to configure the network layer. Now, the PC is an internet host and it can communicate with other internet hosts and servers. A typical scenario for releasing the connection: when the user is finished, network control protocol tears down the network layer connection, link control protocol shuts down the data link layer connection, and the computer will tell the modem to hang up, releasing the physical connection. The second protocol we're going to discuss today is ADSL, Asymmetric Digital Subscriber Line. It's a technology that connects millions of homes and businesses to the internet at megabit per second rates over the old telephone networks. It's very simple. A device called DSL modem is added at the home site or at the user site, and it sends bit over the local loop, telephone loop, to a device called DSLAM, the DSL access multiplexer, at the telephone company local office. A typical scenario will be a PC sends IP packets to the DSL modem using technology like Ethernet. The DSL modem sends IP packets over local loop to the DSLAM using protocols that we are going to study. At the DSLAM, the router or the DSLAM, depends on the configuration, will extract IP packets and enter them to the ISP network where they might reach their destination in the internet. The protocols that are used over DSL links in the physical layer, there is ADSL protocols. They are based on digital modulation scheme called discrete multitone or orthogonal multiplexing. In the second layer, there is ATM, Asynchronous Transfer Mode Protocol, which is data link layer based on transmitting fixed length cells. And asynchronous in the name means that the cells don't need to always be sent, as in the bits continuously sent over synchronous lines like SONET. The cells only need to be sent when there is information to carry. ATM is a connection-oriented technique. For the data to be sent over ATM networks, there should be a mapping between the frames and the cells. The cells are 53 byte cells, 5 for a header, 48 bytes for data. And if you remember, we've said that the maximum load payload size for the point-to-point protocol can be up to 1500 bytes. So 1500 bytes should be mapped into 48 bytes of data. This is a process of segmentation and reassembly, and it's the job of ATM adaptation layer 5. Near the top of the stack, we will find the point-to-point protocol, which does the same functions that it used to do in packets over SONET. A typical scenario will be a PC sending IP packet over an Ethernet frame to the ADSL modem. In the DSL modem, the IP packet will be extracted from the Ethernet frame, encapsulated in point-to-point protocol frame, then into ATM adaptation layer 5 frame, and will be mapped into ATM cells, that's to say segmented. Then the ATM cells will be sent through the ADSL layer on the physical link, the local loop, to the ISP office, where it will be received by the DSLAM and the router connected to it, if that is the configuration. It will first be received by the ADSL layer, and then to the ATM layer, and then to the ATM adaptation layer 5, where the cells will be reassembled to be ATM adaptation layer 5 frames, and then the payload will be extracted and sent to the point-to-point protocol, where the point-to-point protocol extracts the IP packet from its frame and send it to the link layer in the DSLAM, in the router, where it's encapsulated in the frame and sent to the internet to the destination. For the point-to-point protocol to make use of ATM in the case of ADSL, there is a standard that should be in place. It's called point-to-point over ATM, or PPPoA. This standard is not really a protocol. It's more like specifications on how to work with both point-to-point protocol and adaptation layer 5 frames. It is specified that only point-to-point protocol field and payload field are placed into ATM adaptation layer 5 payload. The protocol field is needed to tell the DSLAM what type of protocol the payload carries: IP, LCP, NCP. With adaptation layer 5 frame, point-to-point framing is not needed, and neither the point-to-point CRC, because the adaptation layer 5 has its own CRC. As we can see here, the point-to-point protocol frame has flags to indicate the beginning and the end of the frame. These are not needed because the whole frame will be encapsulated in the ATM adaptation layer 5 protocol frame in the payload. And the address and control, as we have said before, they are both fixed and they can be negotiated to be dropped. So we will drop them. The checksum is not needed because the ATM adaptation layer 5 has its own checksum. So only the protocol and the payload fields are included in the payload of the ATM adaptation layer 5 payload frame. This is all for today. We don't have a reading assignment for this week. Your writing assignment will be point-to-point protocol. See you next Tuesday, inshallah.